So, ito yung first member natin and yung second. So, saan sila nag-meet? Okay? Dito at dito. But under circumstances, we choose this one. Okay? So, dito sa side na to, kung dito tayo maglalagay ng weld sa right side, ito yung magiging root niya. Okay? Ano naman yung tinatawag na throat? Okay? Yung throat o your theoretical throat is the shortest distance from the root up to the hypotenuse of the triangle. Okay? So, ito yung hypotenuse na sinasabi natin. Okay? So, yung root hanggang dun sa hypotenuse is your throat or your theoretical throat. The throat area equals the theoretical throat distance times the length of the weld. Okay? Now, the effective throat distance is taken as the leg size, which is ito, times sine 45 or sine 45 or cosine 45, whichever it is, kasi parehas lang naman yung value niya, or 0.7071. Okay? So, yun yung magiging effective throat distance natin. Alright. So, pagdating naman sa weld symbols, pag ikaw ay isang engineer or kayo as engineers na involved sa design, sa fabrication, and sa construction ng mga steel members na connected by weld, so, dapat alam nyo yung weld symbol. Okay? Pagdating kasi sa mga plans, hindi naman yan sentence na nilalagay dun. Na parang, meron kang steel member dun or pinresentan ka ng connection detail. Hindi naman yan nakasentence ng this side is connected by E70XX using fillet welds. Okay, hindi ganun. We as engineers or someone in the construction or design field or fabrication field, we use weld symbols. Okay? So, yung basic types ng weld symbols natin is ito. Okay? So, pagdating sa groove, iba-iba yan. Meron kang square, scarf, yun yung sabi natin kanina. Diba, pinakita natin yung mga example niya. May V, bevel, U, J, or meron pa iba din na flare V or flare bevel. Okay? So, other than the groove, meron tayong para sa fillet, sa plug or sa slot, and other types of groove weld. Okay? So, paano naman natin pinagsasama-sama yung weld symbol? Okay. So, meron ka ditong parang chart or parang diagram or figure to show the standard locations ng mga elements pagdating sa welding symbol. Okay? So, mostly, ito yung, or ito na lahat. Pero, hindi naman, depende rin kasi sa connection na, or weld na nakaspecify. Hindi naman yan lahat gagamitin eh. Okay, usually, basically, ang ginagamit lang dyan is ito, ito. Ito naman, pag meron kang triangle dyan, meron kang itong parang flag, ibig nun, field weld siya. Ibig sa field na siya wineld or kinonect. Okay. Pag weld all around naman, ibig palibot nung plate or nung steel member or sa thickness niya, paikot or nag-rotate, kumbaga, yung buong weld mo. Okay. Pagdating naman, ano pa ba? Okay. Dito, pag dito nakalagay, halimbawa, meron ka dyang, ano yung ibig sabihin ng other side or arrow side? Halimbawa, meron ka ditong, wait lang. For example, meron ka ditong pag ganyan na meron kang plate dyan. At plate na pag ganyan, nakahang kumbaga. Ito yung magiging, dito ka mag-weld, di ba? Kung nandito yung weld mo, ang connection mo, or symbol mo pag ganyan. Okay, sabihin, kunwari nasa field. So, sabihin pa nasa field, sa field di, ano, ay, laki. Wait lang, ulitin ko. Okay. Kunwari nandito yung weld. Okay. Now, connect mo siya ganito. Yan magiging weld symbol mo. Kunwari nasa field weld siya. Okay. So, meron kang pag ganyan. Okay. Kung fillet weld yan, dapat ang symbol niyan pag ganito. Okay. Sa kabila pala. Dito sa baba. Ibig sabihin, nandito sa side na to, sa tinuturo nung arrow, yung magiging weld mo. Okay? So, halimbawa, ang size niya is 6 meters, or 6 mm, sorry. And yung length niya is nandito. So, let's say, kunwari, 75. Parang ganyan yung magiging, ano niya, magiging location. Tapos, kung i-specify natin, meron ka dyang, kunwari, naka-E60. Okay? Paano naman kung nasa kabila? Pag nasa kabilang side, meron tayo ulit Pag nasa kabilang side, nandito yung fillet mo, fillet weld mo, ang weld symbol mo, okay, let's say, nasa field or field weld pa din siya. Kung fillet or other side siya, dito yan nakalagay. Okay? So, kung 6 ulit yung thickness, size niya, tapos ang haba niya is also 75. Tapos, i-specify natin yung strength niya, which is E60. O, parang ganun lang. So, hindi naman, depende rin, sabi ko nga, depende rin naman sa i-specify kung anong ilalagay mo. Okay? Hindi lahat yan ilalagay mo dyan. Kasi iba-iba rin magiging, ano mo sa types pa lang, iba-iba ng kaagad, di ba? Okay, so let's go to the matching weld filler metal. Okay. The principle sa pag-design ng connection is that the connecting material is always stronger than the base materials. Kung wood man yan or concrete or steel, dapat mas malakas yung connecting material mo. Okay, so ibig sabihin yan, yung matching weld metals natin have to be stronger or mas malakas doon sa magiging base metals natin na pagduduktong natin. Okay, sa NSCP 510, NSCP 510.2.6, merong ditong table ito. For the pre-qualified matching material, and also another table for the SJP groove, and this is reproduced here. Okay, so kung 836 na less than 3/4 3/4 inch thick or 6 mm. So, ang gagamitin mo dyan is 60 or 70 KSI electrodes. Pag more than 36, A36 na more than 6 mm, ito naman ang gagamitin, and so on and so forth. Okay? Now, let's go to the weld strength naman. Okay. Sa NSCP 510.2.4, the design strength, which is your phi, Rn, and the allowable Rn over omega of the weld shall be the lower value of the base material, and the weld metal strength determines according to the limit states of tensile rupture, shear rupture, or yielding. Okay? For the weld material, or for the weld metal, the formula will be Rn equal to Fw times Aw. Pagdating naman sa base metal mo, ang formula natin is Rn times Fbm times Abm. Okay, ano ba yung mga variables natin? Okay, yung Fw is the nominal strength of the weld material per unit area. Your AB or Aw is the effective area of the weld. So, yung dalawang yun is para sa weld, and yung remaining two, the Fbm is the nominal strength of the base metal per unit area, and the Abm is the cross-sectional area of the base metal, of course in square millimeter. Now, the available strengths of welded joints are listed here at the table. 510.2.5 for CJP, and sa next page is yung para sa PJP. Okay? Meron din dito, given na rin yung para sa slot and plug and slot welds, and of course the fillet welds. Okay. So in general, the nominal strength is 0.60 FEXX, except for PJP compression connections not finished to bear, where the nominal strength is 0.90 FEXX. Okay? So, tatandaan nyo lang lagi, 0.60 FEXX para sa lahat except PJP compression connection, which is yung 0.90 FEXX. Okay. Pagdating sa CJP penetration, CJP or complete joint penetration welds, the weld should have at least the same strength as the pieces joined, since groove welds are intended to transmit yung buong load dun sa member na pinag-join natin. Para dun sa full penetration groove welds, the area of the weld is at least equal dun sa area ng base metal natin. Now, since the weld material is stronger, the capacity of connection is generally the strength of the base metal. Okay? Now, pagdating naman sa PJP, or partial joint penetration welds, yung PJP, kailangan siyang i-check din whether yung weld or yung base material is critical. Kasi yung effective area ng weld is mas mababa dun sa area ng base metal natin. Okay? Now, according to the table, so, pwede natin i-summarize yung mga nakasulat dito as for welds, your tension, yung fee natin for LRFD is 0.80 and the omega for ASD is 1.88. Pagdating naman sa shear ng weld, your fee is 0.75 and your omega is 2.00. So, yung base metal naman natin, o yung steel na kinoconnect natin, una doon sa tension and compression or the axial, your fee for LRFD is 0.90 and omega is 1.67. Pagdating naman sa shear, mag-govern siya or it is governed by NSCP 510.4. Okay? So, yun yung summary. Or basically, ito yung values na gagamitin natin. Ito ay karugtong lang ng table. Ito. Kasi mas pag pinilit ko siya dito sa page na to is hindi na masyado makikita yung text. So, I transfer the late part or the last part sa next page. Okay. So, let's go to the plug and slot welds. So, as can be deduced dito sa figure natin, the action of plug or slot welds is shear. Okay? So, shear yung mag-act or shear yung force na mag-act upon this kind of connection. Shear yung mag-act sa contact area, which is defined by the nominal area of the hole or slot in the plane of the faying surface. Okay. So, sabi sa NSCP, the diameter of the holes or for a plug weld shall not be less than the thickness of the part containing it plus 8 mm. Ibig sabihin, your D should not be less than, ibig sabihin, greater than or equal to T, yung thickness ng part, plus 8 mm. Okay. Rounded to the next larger even mm. So, dadagdagan mo siya ng 2 kapag ito ay So, pag even to, dadagdagan mo to ng plus 2, pag add, plus 1. Okay? Nor greater than the minimum diameter plus 3 mm or 2 1/4 times the thickness of the weld. Okay? Again, D shall not, nor greater than. Okay? Dapat less than siya sa minimum the minimum D plus 3 mm or min D times 2.4. Okay, so let's have, okay, meron, other than that limitation, meron ding other limitation for the plug and slot welds sa dito sa section na to in NSCP 510.2.3.2. Okay, so just read it na lang. I won't explain yung other limitations for you. Okay, so let's have now the example. Okay, for example number 1, design the lap splice to develop the full strength of the connection shown. So use A36 steel and ASD. So walang naka-drawing, drawing na lang natin. So I have here so let's use plug or slot weld sign E70. So draw natin yung elevation niya. Okay, so lahat ng plate na to, all plates is PL12 or plates with thickness of 12 mm. So, meron ka dyang T and T. Okay. Ano pa? Width, which is 250. Okay. Now, the full strength of the plate in tension is its yield capacity. Okay. Dun muna tayo sa plate. Or base metal. So again, the full strength of the plate in tension is its yield capacity. So meron kang T equal to A G Fy. Sabi natin kasi kanina AS din gagamitin natin. So over omega. Okay. Now, for A36, your Fy is 248 MPa and omega is equal to 1.67. So therefore, the tension capacity of the plate is 12 times 250 times 248 times 10 negative 3 for conversion over 1.67. So this will be equal to 45.51 kilonewton. Now, pagdating naman sa weld natin, the weld usable capacity based on its shear strength is T is equal to 0.6 FEX times AW over omega. Okay? Now, the required area or required AW is equal to omega times T over 0.6 FEXX. Okay. Yung weld metal tensile strength natin for E70 is, for E70, your FEXX is 70 times 6.9 for the conversion. Para maging MPa is 483 MPa. And of course, your omega is 2.0. So, your required area will be 2 times 445.51 times 1000 for conversion 0.6483, which is equal to 3074.6 square millimeter. Now, therefore, meron na tayong AW. So, para makuha natin yung diameter natin, your required diameter is equal to 4 over pi times 3074.6 square root. So, this is 62.6 mm. So, let's say, sabihin natin 75. Okay, para masimplify natin, round up natin. So, 75 mm diameter. Okay, so that's for our first example. Our example for plug and slot welds. Okay, so let's go to fillet welds naman. The fillet welds that resist tensile force not parallel to the weld axis or proportion to withstand repeated stress shall not terminate at corners of parts or members. Okay, so yung typical fillet natin ay ito. Okay, so meron kang base metals which are not parallel or not in the same plane. So, in this case is perpendicular. Okay, so connected siya with fillet welds. Meron kang ditong root. Of course, you have the leg and your throat. So, katulad lang din sa plug and slot welds, the stress of the fillet weld will always be shear. Okay? Regardless kung saan yung direction ng force dun sa base metal natin. Okay? Now, pagdating sa effective area, according to NSCP 510.2.2.1, the effective throat of a fillet weld shall be the shortest distance from the root to the face of the diagrammatic weld. So, ibig sabihin, the effective throat is given by the expression 0.07701 times W. Or, dito sa case na to, usually kasi sa ibang books, yung leg niya is W or A ang nakasulat. So, mapapansin nyo, basta yung 0.7071 is multiplied dun sa leg size. Okay? Now, pagdating sa limitations, okay, for fillet welds, a minimum size is prescribed on the thickness of the thinner part joined according dun sa NSCP 510.2.2.2. Now, the thicker base metal requires more heat to melt in order that the welding becomes successful. Thus, a minimum size is required since the thickness is directly attributable to the heat generated dun sa process ng welding.
So the minimum size is shown here in table 510.2.4 of NSCP. Okay, so pag hanggang 10 hanggang 6 mm, you have minimum size of fillet weld to 3, over 6 to 13, 5, and so on and so forth. Now, along the edges ng material, mapapansin nyo dito sa figure na to, the corner of the edge material is assumed to be welded off during the process of welding. So, hence the maximum fillet weld A is 2 mm, then the thickness T. Ito. Yung maximum fillet natin na A or W or ano man ang makikita nyo sa mga problem is 2 mm less than the thickness of T. So, if T is greater than 6 mm, pag yung T natin is more than 6 mm, meron pa siyang additional na 2 mm. Okay? For the T na less than 6 mm, the A can be assumed to be equal to the T. Okay? So, ibig sabihin, let's write this off. For the maximum leg size na A, 20 is equals or less than, I should say, less than 6 mm, your A is equal to T. Now, when T is equal to or greater than 6 mm, the A is equal to T times 2 mm. Okay? Now, the length should be more than 4 times the weld size in order that the whole strength is fully effective. Now, otherwise, the size of the weld shall be considered not to exceed 1/4 of its effective length. Okay, so ano ba yung, bakit, ano yung nito or bakit ganun? Okay, so mapapansin nyo, okay, so kung masyadong mahaba yung effective length natin or your LE or effective length is greater than or equal to 4 times A, minimal lang yung area na minimal lang yung area na mawawala or there is minimal area loss pag ganito yung itsura ng weld length natin. Ngayon, pag ganito lang or ganito lang kaigsi yung weld area natin, magkakaroon siya ng considerable amount ng area loss pag ganito kaigsi yung weld natin. Okay? So, I hope you understand the explanation to the fillet welds. Okay, so now let's now have another example. Now for this example for the fillet welds. Okay, so for the second example, determine the size of the fillet weld of the lap splice shown to develop the full length of the connection using A36 steel and LRFD. Okay, so meron tayo ditong 2 plates connected. Mapapansin nyo, we use the weld symbols. Okay, so E60 daw yung strength ng weld natin, and it is a fillet weld with 250 na length. Ibig sabihin all throughout the width of the plate. Ito naman, naka-connect dito. Ibig sabihin, dito sa side na to. O dyan mismo sa side na to, naka-weld. Ito kasi nasa ilalim, kumbaga, sorry. Itong
symbol na to kaya nasa taas is because nandito yung weld natin. And ito, nandito mismo sa tinuturo ng arrow. Kaya nandito sa ilalim yung fillet weld symbol natin. And this is both with weld length of 250 mm. Okay. So, let's go first to the plate or base material. Okay. The tensile capacity of the plate using LRFD, yung phi natin is 0.90. So, our T is phi Fy Ag. Or, we have here 0.90 times 248 for 836. 12 times 250. So, we have here value of T equal to 669.6 kilo Newton. Okay? Now, for the weld naman, okay, the required weld area is, again, your phi for shear is 0.75 and your FEXX is 60 times 6.9, which is equal to 414, of course. Now, yung required area natin, or AW, is equal to T times 0.75, which is yung phi natin, times 0.6 times 414. Okay. This is equal to 3,594.203 square millimeter. Okay. For fillet welds, AW is defective throat times L. Okay? Times 2 natin kasi dalawa yung weld natin. Now, this is equal to 0.70, 71. Let's use A. Your length is 250. And because we have two welds, we have to multiply this by 2. And of course, we have our AW, which is 3,594.203. Ayusin ko lang. So, unknown natin yung A. Okay? So, simplify natin. We will have the value of A equal to 3,594.203 over 0.70 times 71 times 250 times 2. This will be equal to 10.166 millimeter. Now, referring to table 10.2, yung minimum A natin is 4 mm. Sorry, this is not table 10.2. This is your 510.2.4. And yung maximum A natin, because this is already greater than M, kasi ang thickness ng plate natin is 12, diba? So, we have here 12 minus 2. 12 minus 2 equal to 10 mm. So, ibig sabihin, or therefore, use A equal to 10 mm. Okay? So, that is your answer for the second example.